The multiplication counting principle states that if there are A different ways of doing one thing, and there are B different ways of doing another thing, then together to do both things, it's going to be A times B. Those are the total number of outcomes. So for example, if you have 3 shirts and 4 pants, how many different outfits can you create? It would be 3 times 4 outfits. A permutation is an arrangement of items in a certain order. So it needs to be the order matters. So I think of permutations with a P being picky, or order matters. So we use this what's called factorial button. So you can find it on your calculator underneath math. So go to math. You can find the factorial button. So if you had 12 factorial, what that means is it's 12 times 11 times 10 times 9, all the way to times 1. That's 12 factorial. So you use that if you think of an example 1, how many different ways can 10 dogs line up to be groomed? So if I think of, okay, here are my 10 different dogs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if there's 10 dogs, what I can do is pick, of those 10 dogs, I have 10 choices. Then one of those dogs has been used, so now I have 9 choices. Then I have 2 dogs that have been used, so now I have 8 choices. All the way down, multiplying, use the multiplication counting principle, all the way down to 1, where the last dog is. So this is, instead of writing out 10 times 9 times 8 times 7, etc., I can just do 10 factorial on my calculator, and the order matters. So you can do 10 factorial on your calculator and get the answer. Another way is how many different ways can you arrange 6 trophies on a shelf? So using all 6, so 6, 5, 4, 3, 2, 1. So this is 6 factorial. You can do that on your calculator. So you can use permutations not all the way down. See, these were, we have 10 dogs, we're going to use all 10 of them. We have 6 trophies, we're going to use all 6 of them. What if you're ordering something and order matters, you're not using all of them? What you're going to do is you're going to choose, of the 10, you're going to choose 4 of them, and of these 4, the order matters. So when you have n per PR, this means n factorial over the difference between those factorials. So think of something where the order still matters. So for example 3, 8 runners are running the 100-meter dash. How many ways can first, second, and third be awarded? It definitely matters if you have first, second, third, because if Betsy gets first, that's different than Betsy getting second, so that the order matters. So I have 8 people to choose from, P, 3, so 8 people pick 3, order matters, it's picky. So this is going to be 8 factorial over 8 minus 3 factorial. This factorial is on the outside, by the way. It's kind of sloppy, but then this is 8 factorial over 5 factorial. And watch what I can do this with simplifying. You can do 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? And then 5 factorial is 5 times 4 times 3 times 2 times 1. So essentially, these are canceling out. So your answer is 8 times 7 times 6, and you can do that in your calculator. This is how you can show your work. And then down here, in a class of 30 students, how many different ways can you assign 5 different class jobs? Because there's different class jobs, the order matters. So it's 30 P5. So this is going to be 30 factorial over 25 factorial. And then again, this is going to be 30 times 29 times 28 times 27 times 26 times 25, etc. And on the bottom, it's going to be 25 times 24 So it's going to cancel out. So then you're going to be left with 30 times 29 times 28 times 27 times 26. And you can do that in your calculator. Now, sometimes the order doesn't matter. So, for example, if you're going to Subway and you say, I want tomato, onions, and green pepper, you're not going to get frustrated if they do tomato, peppers, or onions. So the order doesn't matter. That's called a combination. So the formula is 5CR, and it's a little bit different. It's 5 factorial, or n factorial over r factorial, and then subtract them. So the only difference with the permutation is this r factorial. And the number of combinations end up being less than a permutation because the order doesn't matter. So that's why you end up dividing by r factorial, and it's going to be less. The number is going to be less. So I'm going to do a couple examples of just these algebraic, and it's very similar to what we did on the last page. So 10 choose 5. I usually say choose for this. 10 combinations of 5. Where you have 10 things and you're choosing 5. The order doesn't matter. Order doesn't matter. So it's going to be 10 factorial over 5 factorial, because that's r, over the difference of 10 minus 5. And then put that factorial, so that's 5 factorial. So in the numerator, you're going to have 10 times 9 times 8 times 7 times 6. Then you're going to have times 5, 4, 3, 2, 1. But on the bottom, you're going to have 5, 4, 3, 2, 1. And then you're going to have 5 factorial. These cancel out. So you're going to have 10 times 9 times 8 times 7 times 6 over 5 times 4 times 3 times 2 times 1. See how those fives cancel out? Now let's do another one. So 8 factorial over 2 factorial, and the difference is going to be 6 factorial. So on the top, you're just going to be left with 8 times 7 because the 6 will cancel out over 2 times 1. So 56 divided by 2. And then the last one is 25 factorial over 7 factorial and 18 factorial. So on the top, 18, 17, 16, 15 is going to cancel out with this. So you're going to have 25 times 24 times 23 22 times 21 times 20 times 19 all over 7 times 6 times 5 times 4 times 3 times 2 times 1. That was a lot to write out. And then you can put that in your calculator. And then the trickiest thing is to think of when do you use a permutation and combination. So I want you to think about whether the order or the assignment or the arrangement or the different positions mattered. So example 5, you have a list of 30 different books to read. How many different ways can you choose 5 books? So I interpret this as you got 30 books, you know, all different titles. How many different ways can you pick up 5 of those? So in that case, the order doesn't matter. So you could pick these 5, you could pick these 5, you could pick these 5. It doesn't matter. You're just grabbing these books. So this is 30C5. So I want you on your calculator or to show your work how to do 30C5. So get that answer. Example 6, you have a list of 30 books to read. How many different ways can you pick 5 books or less to read? Okay, so then we're not just picking 5 books. We're picking maybe 2 books to read or 1 book to read or 3 books to read. So there's going to be a lot of different ways. But again, the order to me, it does not matter. You're just grabbing 5 books to read. So you could read 5 books. You could read 4 books. You could read 3 books. You could read 2 books. Or you could read 1 book. So you're going to add these together on your calculator. Example 7, you have a list of 30 books to read. How many different orders could you read if you pick 5 books? So this is orders to read. So you're picking those 30. You have 30 books. You're picking 5. So maybe you want to read To Kill a Mockingbird first, or Maybe you want to read The Great Gatsby first. This is specifying that the order matters. So this is going to be 30p, exactly 5. It doesn't say 5 or less. So it's 30p5. That's really sloppy. And you want to put that in your calculator. There's going to be a ton of different orders. Example 8, you have 20 topics, 20 different toppings, 20 different yogurt toppings. At Sweet Yo's, how many different combinations of toppings can you choose if you pick 3 or less? So even though it reads combinations, I still have to be careful if we're talking about combinations. So if you're going to Sweet Yo's, does it matter if you put Heath Bar first or if you put Oreos? The order doesn't matter. So this would be a combinations, and it reads 30 or less. So it's going to be 3 or less. So it's going to be 20 C3 plus 20 C2 plus 20 C1. And I'm going to add that person that doesn't pick any yogurt toppings and is weird. So we have to count if you don't pick any yogurt toppings. And I guess we could argue about whether that one should include 30C0 or not. How many different ways could you pick 5 books or less? I guess you could pick no books. It's kind of weird, but we have to include no books. So 30 choose 0 is going to be 1, and that's going to be 1. Example 9, how in a class of 100 freshmen, 5 will be chosen. For student government, how many different combinations are there? So even though it's combinations, you have to think about whether or not order matters. So if you have 100 freshmen and you're just picking 5 people, it doesn't matter if I read off Allie Ashley or Ashley Allie first for my 5. So this is going to be a combination, 100 C5. And then the last one, in a class of 100 freshmen, 5 will be chosen for student government. Secretary, VP, president, treasurer, and the candy bringer. Very important job. How many combinations are there? So it's reading combinations, but again, I have to think about if the order matters. In this case, yes, it does, because I'm assigning specific positions. So if I pick Allie for secretary, that's different than picking Allie for VP. So picking that, assigning a role is making a difference. So in this case, it's a permutation. So it's going to be 100 P5. And with all of these, I want you to put them in your calculator and get a final answer. So I'm going to put this one in my calculator. I go to 100 math probability. And then make sure you're clicking the combinations button, or permutations for this one. Huge number. So it's 90345024000.